This paper describes some work done at the University of Brighton to make it very easy for a student to make three-dimensional objects from laser scanned data. Here's a body scan, and they can produce three-dimensional parts from any material. This has been very difficult to do in the past. It's involved students in huge learning curves, and even for an engineering specialist it's not easy. But this, we believe that we've simplified it as much as we can. The program runs in a web browser. It's not limited to any particular computer. It runs over the internet. It's simple for students to use. Everything is automatic. Surface errors are fixed automatically. The CNC file is done automatically, and the whole thing works with about 3 or 4 clicks of a button. And let's have a quick look at it working. So I'll now give you a demo of the software. Right, the link to the page with the software on is on the bottom of the paper. The video here shows you the machining process, which is what we want to get towards. So we're going to work with a CAD model, which will come from a CAD system, or laser scanned data. The laser scanned data will look like that. It'll be in STL file format, and here's an object which is a torso that's been scanned in. Now this is coming straight from the laser scanner, and if we look at it you can see there's errors in the surface. Under the chin there's a huge hole. I think under the armpit there's another hole there, and there are gaps at various other places. Now this would cause chaos for a typical engineering package. There's a gap there which with the cutter would just go straight through it. And the work that we've done, we're using a new algorithm, and we run a ball end nose mill or a ball nose cutter, this type of thing, which is a sphere on the end of a cutter, over the surface. So we start off, this is the software now, there's the link. So let's have a quick look at how it works, and I'll show you how the model is produced. So we load in the laser scan data, and there's the model. It's in STL file format, and it's loaded in. The dimensions here, this is 450mm by 700, and it's going to be quite thick, so I'll give a thickness of 300, and that's all we do. And then we just hit prepare, and this is building up a much more detailed 3D binary object. This does take quite a long time, so I'll skip a couple of minutes, and now it's finished. We have the side view here. This distance here is 300mm, 700mm is the length of the block. The top view, that's the top of the block. So we've now created the 3D binary model, and now we just hit cut. There's an invert button on there to turn the object upside down when you come to do the other half, but initially we're just going to cut the top half. So cut, and then we just wait here while it does the cutter path analysis. Again, I'll just cut for a minute. The model has been cut in 20mm layers. So far it's taken about 10 minutes. And then now it's finished. So this is the showing you the final cutter path. This is the finished object, just the top half. So now we save it. I'll save it back into the same folder. I'll give it the same name, Porsche.tap. That saved it. So now in our folder we have the original STL file, and we have the cutter path file, which is what we now give to the machine operator. And just have a quick look inside that. This is what the file contains. Everything the machine operator needs to know is in this file. You can just feed it into the CNC machine and your object will appear. And that's all there is to it. This is the picture of a typical CNC machine. There's the bed. This is how the workspace is set up. These are your coordinates. The object is placed with the origin there, and the rest of it should be fairly straightforward. If there are any questions, or anybody wants to work on a collaborative project, this is my email address, and I can be contacted there. Thank you.